It would be very helpful if you first try to solve the problem yourself before watching this video.
Question 296. Suppose the function f is twice differentiable and the table above gives selected values of f, f prime, and f double prime. Which of the following about the graph of f at x equal -1 is true? Here we have answer choices, and they mention relative minimum, maximum, point of inflection, right? Well, f has a point of inflection if f double prime changes from positive to negative, right? Which means at the point, second derivative has to be equal to 0 or undefined, right? At x equal -1, second derivative is 2, positive 2, right? Then that means we do not have point of inflection at x equal -1. So C is not true. Now let's look at answer choices A and B. Does f have a relative minimum or maximum at x equal -1? Here, at x equal -1, f prime is equal to 0. Slope is equal to 0, right? F double prime is positive. Then f is concave up, right? Using the second derivative test, here, second derivative test says that, number 1, if f prime, let's say A, is equal to 0 and f double prime A is positive, then think about the graph of f. You know, it's concave up, and slope is 0, right? Slope is equal to 0. Then we will have relative minimum at this point, right? So let's say here's the x-axis, here's the y-axis, and this point is A. Number 2, if f, let's say f prime B is equal to 0 and f double prime of B is negative, then what happens? Since f double prime is negative, the graph of f is concave down, right? And slope is 0. Slope is 0. Then we have relative maximum at x equal B, right? Does that make sense? So that's the second derivative test. So here we have f prime is equal to 0 at x equal -1 and f double prime is positive at x equal -1, right? F prime is 0, f double prime is positive, then it is concave up, slope is 0. We'll have minimum at this point, right? So we have, f has relative minimum at x equal -1. So the answer has to be A.